All right, everybody, this is Mr. Ainsworth, and we're going to get into final review one for your 2019 prep for your final and second semester Algebra 1, okay? So let's see here. Let's get right into it here. Oops. Let me make sure I'm in tablet mode. I'm good. I'm in tablet mode. We're ready to rock. Okay, so uh, this is a final review, right? So use your video effectively. Pause and play when you need to. Listen to it once or twice, whatever it takes to understand the concept. Use your notes, put all the key points in red, all right, and do what we normally do. Do a good job and find your strengths and weaknesses and highlight the ones you're not good at it so you can go home and practice whatever you're not good at, okay? Because you are prepping for your final. So let's get right into it. We got f of x equals x squared plus 3 minus x, when we want to find f of 2 where x is 2. All right, so what we need to do is substitute in wherever you see x. All right, x is in this case 2. F of 2 means f of x where x equals 2. So you take 2 and substitute where where we see x. So f of 2 in this case is equal to 2 squared because it's x squared plus 3 more minus whatever x is, and x is 2. Then you follow the order of operations from left to right. So 4 plus 3 minus 2. 7 minus 2 is obviously 5. Okay, so we say f of 2 is 5. Okay, and there's answers attached. So you should check your work as you go. And that way it'll be, you'll find out what you're good at and what you're getting correct and what you're not. So always check as you go. Okay, so let's continue here. By the way, I am not going to do every single problem in this review. I'm going to do one of each category or one of each type. Like numbers 1 and 2 are the same. So right here, you have to substitute in whatever x is, and x here is -8. So you got to substitute in -8 where you see x here twice and then evaluate. And then you can check your results on the back here because I always give you guys the results. So don't expect me to do every single problem. I go over the main concepts. I'll talk about the main ideas, and then it's up for you to practice and check your work. Okay, so on this next one here, I'm going to do number 4 instead of number 3 because number 3 is too easy. It's in slope-intercept form. So you're given the slope and the y-intercept. So you have to decide what is the slope and what the y-intercept is. Over here, you have to isolate y, all right, and get it into slope-intercept form, which is y equals mx plus b. So I'm going to do this one instead. So we have 5x minus 2y is equal to 2, excuse me, -2. So we're going to subtract 5x first and get it in slope-intercept form. So we have a -2y, not 2y, but -2y is equal to -5x minus 2, dividing everything by -2. I mean all three terms. You get the final result of y is equal to 5 halves, the negatives cancel, right here. All right, x plus 1. So the slope's 5 halves and the y-intercept's 1. Right here, so we're going to start at 1, and we're going to go up 5. All right, right 2. So a 5, 1, 2, 3, 4, 5, right 2, and then draw your line. Okay, again, up 5, okay, up 5, right 2. And that's, it's rise over run. So the slope is always rise divided by run, as you guys already know. This is semester 1. Okay, another semester 1 topic, okay? And what you want to do is use point slope form. Point slope form. You can research that on the internet if you like. You just type in those words. Y minus y1 is equal to m times x minus x1, where your slope is given, it's 5 halves, and your point given is x1 comma y1. So all you do is substitute in. So we have y minus the 5 is equal to your slope, 5 halves, times x minus the x coordinate of 4. All right, distribute through. So you have y minus 5 is equal to 5 halves x minus 5 halves times 4. So let's do a little side work. 5 halves times 4 equals 20 halves, which is 10. 5 times 4 is 20. And so it's minus 10. Add 5, and you're done. You have y equals 5 halves x. All right, and 5 minus 10 is -5, so minus 5 there. So your equation is y equals 5 halves x minus 5. That's your end result. Okay, next one, same type, but you got to find your slope first. So slope is equal to 1 minus a negative 4. Okay, y2 minus y1. In fact, let me write that down. So y2 minus y1 divided by x2 minus x1. This is semester 1 as well. Okay, and then what do you get? Well, you get 1 minus a negative 4. Not 1 minus 4, 1 minus a negative 4. It's always subtraction. Then you go with 0 minus 2. So divided by 0 minus 2. I see a double negative here. So you get 5 divided by negative 2. And there's your slope. Now, use the same thing that we did before in the earlier problem. Y minus y1 is equal to m times x minus x1. You substitute your point and your slope in. So y minus, I'm going to use this one, it's easier. So y minus 1 is equal to your slope, negative 5 halves. Okay, times x minus the x-coordinate. X-coordinate x1 is 0. Okay, so it's 0. So you have y minus 1 is equal to negative 5 halves times x, and then add 1 and you're done. So you have y is equal to negative 5 halves x, all right, plus 1. Final result. Okay, so these two problems are related, both semester 1 topics. Okay, this final is not just semester 2, semester 1 and 2, so you have to actually know what you learned earlier, okay, to graduate. Okay, so multiplication, here we go. This is unit 6. No, unit 5. Okay, so unit 5 on multiplying polynomials. So distribute, always distribute first. Okay, distribute twice. So here we go. 6x squared times x is 6x cubed. All right, add the exponents. Minus 6x squared times 1, which is just 6x squared. And it's in standard form. So you're good. All right. Standard form means high to low in terms of the exponents. Same thing here. 3 times 5m is 15m, plus 3 times 4 is 12, and you're done. You just distribute twice. The most common mistake people make, all right, is they don't distribute twice and they think the answer is 15m plus 4. All right, this is wrong. Okay, you got to distribute twice, as I said over here. Key concept. That's if you distribute through a binomial, which has two terms. Okay, now when you multiply binomials, I'll do one of these. You want to distribute or use the FOIL method. Either one, same thing. All right, so 6x times 6x is 36x squared. 6x times 3 is 18x. 7 times x is 42x. And then 7 times 3 is 21. And then when you add like terms, you get 36x squared plus 60x plus 21. Okay, that's a 60x right there. All right, final result. Okay, and then you could do number 10 and check it. Okay, when you find all the zeros, that's the same thing as x-intercepts. Okay, and that's the same thing as your roots. Okay, same thing. To do this, you set y equal to 0 and solve for x like you always do. We did this in semester 1 and 2. So set it y equal to 0 and solve for x. This was on the last test. So it should be familiar. So 0 equals, all right, 5x squared plus 9x minus 2. You can solve, you can use factoring, quadratic formula, completing the square. You could use any method you want. So use any method. Okay. I'm going to use factoring. Okay, so because I think this is factorial. So you multiply 5 times negative 2 to get negative 10. So what two numbers multiply to negative 10 and add to 9? And that's going to be negative 1 and 10. Right? So here we go. So 0 is equal to 5x squared plus 10x minus x minus 2. 0 is equal to 5x times x plus 2. Distribute out on the negative here, so negative 1, distribute out negative 1, and you get times x plus 2 again. So final result, you get x is equal to x plus 2 times 5x minus 1. And then you want to use the zero product rule. So x plus 2 equals 0. And then 5x minus 1 equals 0. Here x is negative 2. And after you add 1 and divide by 5, you get x equals 1/5 here. Okay, so you get your x-intercepts negative 2 and 1/5. All right, which happens to be negative 2 comma 0 and 1/5 comma 0. Okay, so the end results right here. Next one here, same thing. So 0 is equal to 2x squared plus 7x plus 3. You guys can do this one and check your results. Same thing on these problems here. When I say find all the roots, that means solve for x when y is 0, and y is already set equal to 0. All right, y is already set equal to 0, so you're good to go there. And you could solve by factoring or by quadratic formula. This one's factorable, so what two numbers multiply to 5 and add to negative 6? And there obviously it's 1 and 5. So you can factor this, or you can use a quadratic formula. I shouldn't have, this is different. So you could factor if you want. It's factorable. I'll tell you what, I'm going to use the quadratic formula a, b, and c. So x is equal to negative b, so 6 plus or minus the square root of 36 minus 4 times 1 times 5, all divided by 2 times 1. So I see 6 is equal to 6 plus or minus the square root of 36 minus 20, which is square root of 16 divided by 2. That gives you 6 plus or minus 4 divided by 2. So that gives me two answers, 10 halves and 2 halves. All right, 2 halves. So 6 plus 4 is 10 divided by 2, and 6 minus 4 is 2 divided by 2. So x is equal to 5 and 1. All right, so my roots are 5 comma 0. All right, 1 comma 0. So right here, this gives me this. Okay. All right. Oh, you know what? I said solve by factoring. I should have solved by factoring. Whoops. Okay. Got to read the directions here. I told you it was factorable, but I just want to illustrate the quadratic formula. So I'll do one more. So on this one here, what two numbers multiply to 4 and add to 4, and they're 2 and 2? So x squared plus 2x plus 2x plus 4 equals 0. First group here, x times x plus 2. Second group, 2 times x plus 2. So your factors are x plus 2 times x plus 2. And so when is x plus 2 equal to 0? Well, x equals negative 2, which tells you that you have a root at 2 comma 0. Okay, so you can do the rest, okay, because it says solve by factoring, so these are factor. So solve, all right, by factoring. You guys can do that. Okay, this is the FOIL method here on this one, on number 17. So I'm going to do it just one more time. So 2 times 2 is 4, 2 times negative 4x is negative 8x, and then I have a plus 8x, and then I have a minus 16x squared. These cancel to 0, so the end result is 4 minus 16x squared, which is the same as negative 16x squared plus 4 in standard form. Now these right here, you have to take x minus 7 times x minus 7, right, when you square binomial, which is on the test, squaring a binomial. So you go back to basics, you multiply by itself. So x times x is x squared minus 7x minus 7x again. You always have two of the middle terms, and that's why I told you guys to square multiply double square, and you get x squared minus 14x plus 49. So if you want to square multiply double square, square multiply double square, the last, you can use that too, because you always have two of the middle terms. You can do the same thing here on number 20. Okay, so we have those right there, so you guys can finish that. Okay, number 21 and 22. Okay, 21 is addition, And then you can do 22, and then I'll do 21 and 23, and then 23 is subtraction. So when it says find the sum, you add, okay? When it says find the difference, you subtract. And when you subtract, you distribute through the negative. So it's a little bit, the subtraction's a little more involved. The most common mistake is that people don't do this, distribute through the negative. So I'll do one of them. So regroup like terms. Step one. All right. Step two, simplify. So starting with the fourth degree. So I see a 4x to the fourth. I see a minus 5x to the fourth. And then in second degree terms, I see a minus 7x squared, and I see a plus 2x squared. And then I see first degree 4x, and then I see the constant 4. So step two, simplify. 4 minus 5 is a negative 1, so negative 1x to the fourth. This group here, a minus 7 plus 2 is a 2 minus 7, or a negative 5, x squared. Notice that the degrees don't change. All right, plus 4x plus 4. All right, all right, all right. 22 is the same thing. Okay, now when it comes to subtracting polynomials, you got to distribute through the negative. So on the first polynomial, just drop the parentheses. So you have 5x squared minus 8x to the fourth minus 4. And then in red, you distribute through the minus sign. Think of it as like multiplying by negative 1. Negative 1 times 3x to the fourth is a negative 3x to the fourth. Negative 1 times negative 7x squared is a positive 7x squared. And then negative 1 times positive 3 is obviously a negative 3. So you need to do this, okay? And then regroup. Okay, so fourth degrees first. So I see a minus 8x to the fourth. I see a minus 3x to the fourth. Then I see some squared terms. I see a positive 5x squared, and I see a 7x squared. And then I see some constants. I see a minus 4 and a minus 3. So all you do is combine like terms, add the coefficients. Negative 8, negative 3 is a negative 11, x to the fourth. Notice that the degrees do not change. Degrees do not change. Okay, they only change in multiplication, not addition and subtraction. Okay, and that's what it means to be like terms, guys. When you add like terms, you get the same term. So you get 5x squared plus 7x squared is a 12x squared, and then a minus 7. When you combine the negative 4 and the negative 3 is a negative 7. All right, 24 is the same. So remember, you got to focus in on the operations, add or subtract, one of the two, both of which are on the test, by the way. Okay, next major concept. This is in Unit 7. Okay, so your quadratic unit. This is in vertex form. So that means y is equal to a times x minus h squared plus k, where the vertex is h comma k. And your a value, a determines whether it goes up or down. So when a is positive, okay, the parabola goes up. When a is negative, all right, the parabola opens down. All right, you should have learned that through the unit. So here's a, and there's h and k. So the vertex is negative 1, negative 3. A is negative 2, so it opens down. That's the first thing I know, okay? So you plot negative 1, negative 3, and then you draw the line of symmetry like you were trained to do, all right? Every single time it helps you plot and reflect, okay? Plot and reflect. Use the skills that you should have learned. So you go right 1 and down 2, right 1, left 1 and down 2, or you can do reflect it. And then instead of going right 2 down 4, you're going to go right down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then reflect 2 units on the other side. And then draw your parabola. It's a nice smooth U-shaped curve, as you guys should know. All right. So remember, parent on this one. All right. A is negative 2, so refer to your notes. Okay, here A is 1. So A equals 1. All right, opens up. All right, vertex HK is 3, 3. So you start there. Go right 3, up 3. Draw your line of symmetry. And then go right 1 up 1, reflect, right 2 up 4, reflect, and draw your curve. You guys should be able to graph these things seriously in 60 seconds if you know what you're doing, if you guys actually paid attention and learned something. All right, because it's not that hard in vertex form. It's only hard in standard form. Okay, the next two are on you. You guys do that, okay, and check your work. Okay, write an equation. Okay, these are exponential functions. So get your notes out. All right, exponential functions. All right, y is equal to a times b to the x power. Okay, so let's plot some points. So on this one here, this point right here is 0, 2, sorry. 0 and up 2. And then another point on the graph that we know is right here. We'll call this one A. And then at B, that's at 1, 6. Okay, so you got to find A and B on this graph. So find, oops, sorry guys. So find A and B one at a time. So to find A, all right, you substitute it in. So if 0 is equal to A times B to the x power on this graph, then y is 2 and x is 0, I substitute it in. So 0 is equal to A times B to the 0 power. Well, B to the 0 power is 1, right? So B to 0 power, using the 0 power rule, this is also in the same unit here, all right, is equal to 1 by definition, as long as B is not equal to 0, all right? It's a 0 power rule. Okay, so that's 1. So we now know what A is. So A is equal to 2. So now I have y is equal to 2 times b to the x power. Okay, so now let's use it. So now we use point B. So we use A first. Okay, so use point A. A is 0, 2. That's step 1. Step 2, all right, use point B, which is at 1, 6. All right, so let's do it. So 6 is equal to 2 times b to the first power. Well, that gives you 6 is equal to 2b divided by 2, and you know what b is. So now you know what the function looks like. So let's put that in red. So y is equal to, let me see, a is 2, b is 3, right? So you get 2 times, all right, 3 to the x power. So this is your exponential function. If you put that in the TI-83 or TI-84, all right, you can check, all right, with a TI-84, okay? Just put the function in and you'll see it's the same graph. Okay, now on this one here, same idea. All right, so A at 0, 4, point B is right up here at 2, 16. So you guys can work on this one and check the answers in the back. All right, find A first using the first point, find B using the second point. It's not that hard, okay? And again, do that also here too, all right? These are the same type, so you get some practice. Okay, so it's still in the exponential function unit, okay? So, or properties of exponents. So this is the properties of exponents unit. Properties of exponents. Okay, so here we have multiply, we're multiplying like basis, so we add exponents. So we have 3 to the 4 plus -2, which is 3 squared or 9. Here we have 2 to the -6 plus 5, which is 2 to the -1 power, or 1/2. This is 1 right here, so this is just 2 to the 5th power, or 32. And this is 3 to the -1 plus 2 power, or 3 to the 1st, or 3. I mean, very simple. It's the same idea over and over again. You have to understand your properties. All right, when you multiply like bases, you add your exponents. So this is 3 to the 3rd plus -6, so 3 to the -3 power, which is 1 over 3 cubed, or 1/27th. All right, and you can do the next one. Okay, on these right here, I'll do number 40. So we're going to regroup because you can only multiply like terms. So you multiply the constants first. All right, I see um, 3 times 3 times 3. Second group, go alphabetically. Okay, and then x times x squared. Third group, y cubed times y to the fourth times y cubed. So what do you get? You get 27 times x to the fourth. You add exponents again, just like I did previously. And then here you got 3 plus 4 plus 3. That's y to the 10th power. So you regroup and simplify. That's all you do. Okay, and that's how you handle all of these. So you guys can do the rest. Okay, next set. Let's see, sketch the function. All right, so you probably want to do a table of values. So we have 3 times 1/2 to the x power. And like I said before, you want to evaluate a lot of points on these functions to get good. Okay, so this is 3 times 1/2 to the negative 3 power. So it's 3 times 2 cubed. 8 times 3 is 24, so you get negative 3 comma 24, which is off the grid. Next one, you get 3 times 1/2 to the negative 2 power, which is 3 times 2 squared, which is 3 times 4, or 12, and I can plot that one. So I can plot from here down. So left 2, up 12. So right there, there's negative 2 comma 12. So, it's always good to check as you go here. Okay, and by the way, the base is 1/2. Okay, so the base right here is equal to 1/2, and that's a decay function, which is a decreasing function. So this is going down and not up. Going down. All right, that's what happens when you have a base 1/2 or 1/3 or 1/4. Look at your notes. All right, check your notes on this one. Check. All right, use your notes because you have a full-on notebook on this. Use your notes. Get out your yellow notebook. We did a ton of them. Okay, now -1. So you have 3 times 1/2 to the negative 1 power, which is 3 times 2, or 6. I'll plot here in a minute. This is 3 times 1/2 to the 0 power, or 3 times 1, or 3. This is 3 times 1/2 to the first power, or 3/2, or 1.5. And this is 3 times 1/2 to the second power, 3 times 1/4, or 3/4. And this is 3 times 1/2 to the third power, which means you have 3 times 1/8, which is 3/8. So when you graph these points, you got to graph -1 comma 6, which is here, and then 0 comma 3. It's called the y-intercept at 0 comma 3, which is a key point on this. So it's look, whoops, not low. Look for this point. Look for this point, okay, on the exam. This is a key point because this is a multiple choice exam. All right, so write that down and look for that point because the 4 graphs given on a multiple choice exam will probably have different y-intercepts. And if you find the y-intercept, which is always when you substitute 0 in for x, this is your y-intercept right here. Whenever you substitute 0 in, you get the y-intercept. You go back and look at your notes. We identified that every single time. You could differentiate the graphs and know which one's correct just by looking at that. Okay, so next one, 1 comma 1.5, and then 2 comma 3/4, 3 comma 3/8. Okay, and then you draw your curve. It's a decreasing exponential decay function, and it's asymptotic to y equals 0. So the HA here is the horizontal asymptote is y equals 0. So here's your horizontal asymptote right here. Okay, so it's a decay function. Okay, it's decreasing, it's going down. Okay, a lot different than 45 and 46. You could do 44. It's in the same genre. Okay, this is also decay right here. Okay, base is 1/3. Okay, but you do your table of values. Okay, I'll do this one here. This is growth. All right, base is 3. It's growth function. So it's increasing. It's going up. If you look at your notebook, you'll see that all growth functions go up. So on this one here, let's set up a table of values. So it's 3 to the power of x plus 2. If you look at your notebook, I always evaluated the function at many points. So step 1 is to substitute in. So 3 to the negative 3 power plus 2 is 1 over 3 cubed plus 2. 1/27th plus 2 is 2 and 1/27th, which is a little bit bigger than 2. So we go left 3 up a little bit more than 2. We'll graph all these in a minute. Negative 2 is 3 to the, 3 to the negative 2 power plus 2. That's 1/9 plus 2, or 2 and a ninth. Negative 1, so you have 3 to the negative 1 power plus 2. That's 1/3 plus 2, or 2 and a third. 0, 3 to the 0 power plus 2 is 1 plus 2 is 3. There's your y-intercept. So like I said before, you ought to know your y-intercepts. Okay, it's right here. And identify them, because when you're on a multiple choice test, if you know the y-intercept, you can just look at the answers and probably predict the right one just by looking at the y-intercept itself. It's a key point. Okay, so at 1, 3 to the first plus 2 is 5, and so on. 2 is 3 to the squared plus 2. 9 plus 2 is usually 11. Okay, so here we go. So left 3 up 2 and a little bit. So left 3 up 2 and a little bit, right about here. And then left 2 up 2 and a little bit. And then left 1 up 2 and a third. And then up 3. Here's your y-intercept right here at 0, 3. 1, 5, and 2, 11. So the function looks like exponential. It takes off upward. It's growing exponentially. Much different than linear functions. Your horizontal asymptote is at 2. You could have predicted that right here. I already know that my horizontal asymptote is y equal to 2. And this question is also on the test, by the way. The range y is greater than, not greater than equal to, strictly greater than 2. Remember, this function approaches 2 but never touches it, never crosses the horizontal asymptote. So the y values will never be 2. Okay, I don't care how big of a negative number you put in here, it will be 2 and a little bit. Okay, all the y values, remember the range is a set of y values, have to be greater than 2. Okay, and number 46 is similar to this. Okay, so you do number 46. All right, quadratic function time. Okay, you can do this multiple ways. Whoops, what happened here? Let me just check something. Yeah, we're good. Okay, so 2 methods possible. Okay, so first method, you can find the vertex. Okay, using x is equal to negative b over 2a. Okay, and then use the a value and use parent values. I'm going to do it that way. Second method, you can write in vertex form. So it's a multiple choice test, so you get to pick your method. So you pick. All right. So I know I know that A is 1, B is negative 6, and C is 13. So A equals 1. What I need to do is find the vertex. So x is equal to negative of a negative 6 divided by 2 times 1. Okay, and that's 6 divided by 2 are 3. And then I got to find y. So y is equal to 3 squared minus 6 times 3 plus 13. So y is equal to 9 minus 18 plus 13. So y is equal to negative 9 plus 13, or y equals 4. So my vertex is 3 comma 4. So I can plot that, 3 comma 4, and then start. My a value is 1, so use parent values. Okay, and then you go right 1 up 1, and then right 2 up 4. And then reflect it. So plot and reflect. So when you draw your curve, your parabola, all right, draw it smooth. Oops. Got to go through the points. There you go. So once again, use parent values. The correct pair of values, okay, a equals 1. All right, the pair of values for this function are for this parent, which is x squared, is 1, 4, and 9, okay? Square of 1 is 1, 2 squared is 4, 3 squared is 9. That's when a is 1. If a was 2, all these y values would be doubled, okay? All right, and then you guys can do the rest, okay? And check your solutions, obviously. Okay, next one. I'll do a few of these here. This is section 6.2, all right, in your notes. So keep that in mind. So square root both sides. And p is equal to plus or minus 5, which means 5 and negative 5. All right, two solutions here. Now, if it's not isolated, you want to isolate first. So I'll do one more. Okay, so in this one here, you want to add 4, and you get n squared equals 1, and then you square root, and you get n is equal to plus or minus 1. Okay, you guys can do 52 and 54. Okay, on this one here, you want to use factoring, okay, and the zero product rule, because this is used a lot. And if you look in your notes, section 6.1, I believe it's section 6.1, all right, you will check out a lot of examples there, okay? So here, we just set each factor equal to 0, because it's already a zero product, all right? So this one's easier than you think, all right? You got to figure out what makes them 0. So add 4, you get 3x equals 4, divide by 3, and the first answer is 4/3. All right, subtract 4, second answer is negative 4. So my roots, okay, are, okay, 4/3, comma 0, all right, and negative 4, comma 0. You do the same thing here, okay, for number 56. Number 57 is not a zero product, so you got to factor first. Okay, and then step 2, use zero product rule. Okay, so let's play the game. So what two numbers multiply to 28 and add to 1? All right, and the obvious answer would be negative, let me see, positive 4, no, negative 4. Negative 4 and positive 7. 7 times negative 4 is negative 28. 7 minus 4 is, no, that's not it. What happened here? It's not factorable. 14. Oh, I put the wrong number down. This is supposed to be 3. Duh. Okay, 7 minus 4 is 3. Yeah, I knew it was factorable. Okay, so negative 4 plus or times 7 is negative 28, and 7 plus negative 4 is 3. So factor. Okay, so here we go. So x squared, all right, plus 7x. You can put these in either order. Minus 4x minus 28 equals 0. Okay, first group, you get x, whoops, x times x plus 7. Factor out a -4, you get x plus 7 again. Continue factoring and get into a zero product. And then set them both equal to 0. You get x equals -7, x equals 4. Okay, all right, and you can do the rest. Okay, now on this one here, this one is not factorable. Okay, so I'll try it. So what two numbers multiply to 5 and add to a -8? And there are none. So this is non-factorable. All right, so use the quadratic formula. So to do that, you have to know it. So -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So a, b, and c. So x is equal to negative of a -8 plus or minus the square root, -8 squared minus 4 times 5 times 1, all divided by 2 times 5. So x is equal to 8 plus or minus the square root, 64, minus 20, all divided by 10. So x is equal to 8 plus or minus the square root of 44, all divided by 10. Do a little side work. So square root of 44 is square root of 4 times square root of 11, or 2 rad 11. So this is 8 plus or minus 2 rad 11 divided by 10. Then simplify and divide by 2. So my final answer is 4 plus or minus rad 11, all divided by 5. And then make sure you check your work, right? So on number 59, let's look at the answers here. All right, they are correct. Okay, good. Okay, so you have two values of x there, 4 plus root 11 divided by 5 and 4 minus root 11 divided by 5. So x is equal to 4 plus root 11 divided by 5 and 4 minus rad 11 divided by 5. Two solutions. Two solutions possible here. Okay, going back to semester 1. All right, solving by system by graphing. So here you're looking for the intersection point. That's the solution. Okay, that's the key. So you graph them first. So slope and y-intercept. So negative, starting at 3, you go down 4, right 1, down 4, right 1. Slope of -4. Slope of -4 means down 4, right 1. So you sketch your graph. Okay, so this is y is equal to -4x plus 3. Sketch the other graph, slopes 1, the y-intercept's -2. So go up 1, right 1. I just found it, up 1, right 1. So as soon as you plot many points, this is y equals x minus 2, you can see the solution. It's right here. All right, it's 1, -1. So again, you're looking for the solution, which happens to be here. You guys can do number 61. Oh, yeah. Okay, there you go. And that is your first review. Okay, first, because this there's a lot more concepts on the test, and we're doing this over multiple days because guess what? This is a yearly final, so you guys have got to be good. Okay, now I didn't do everything, but I gave you one of every group, one of every single type of problem, and part of preparing is practicing. All right, doing more than enough, doing it so that you understand it, remember it, good at it. You're also fast at it. You have to know it, but you also have to be quick at it. All right, so you have to practice and be good. Okay, so do your best, make yourself proud, and I'll see you in my next lesson. Bye-bye.